Okay, so this is the key to worksheet 10.5, part E. And in number 1, you want to find the equation of the line with the given information. All right, so in part A, you are told that you have this horizontal line that passes through this point, and you want to find the equation of this horizontal line. So you want to find the equation of a horizontal line that goes through this point right here. Now, in these cases, it may help some of you to have a graph paper, so that way you can graph the situation, and then when you graph the situation, you may remember some ideas that you learned in previous lessons. For example, in letter A, you're told that this horizontal line passes through the point -3, 4. All right, so here's -3, 4 right here, and you have this horizontal line. So I'm going to draw, let me put -3, 4, -3, 4. All right, and then you have this horizontal line that passes through this point. All right, so here's a horizontal line. And the question is, what's the equation of this horizontal line? Well, remember, with a horizontal line, if you look at any point on this line, no matter what point you look at, and you learned this from a previous lesson, but if you look at any point on that line, you will notice something about the y-coordinate. The y-coordinate for every point on this line, no matter what point you're looking at, the y-coordinate is always going to be 4. So what that means is that y has to always equal 4 no matter what x is. So if x is, let's see, this one's 1, so if x is 1, y is 4. If x is 1, 2, 3, 4, if x is 4, y is 4. If x is, let's see, that's -3, 4, 5, 6, 7. If x is -7, y is 4, and so on. So that means that y always equals 4. So you learned in a previous lesson when we graphed lines that whenever in this particular case, whenever the variable x is not appearing in the equation, you're dealing with the horizontal line. All right, so remember when we did the t-table, this says that y always equals 4. So we in the y column, we said y always equals 4 no matter what x is, and so on. All right, and so when you plotted those points, you ended up with a horizontal line. So if you're dealing with a horizontal line, you have to remember that you are looking at an equation where y equals a number. That's what you're looking at, y equals a number. And so you're just going to look at this point here, and you can look at the y-coordinate. Well, the y-coordinate is 4, so that's going to be y equals 4. All right. Now, in letter B, you're dealing with a vertical line. All right, so if I plot the point 5, -2, 5, -2, so here's 5, here's -2. And remember, that's 5, -2. And so if I draw the line, the vertical line that goes to that point, 5, -2, I get this vertical line. And so in that same section that I'm referring to, we talked about horizontal lines and vertical lines. And so when we talked about graphing a vertical line, we noticed that no matter what point I look at on this vertical line, no matter what point I look at, it turned out that the x-coordinate was always the same. The x-coordinate was, in this case, was always 5, no matter what y is. That's what we had learned. So what that means is that when I did a t-table, we saw that the x-coordinate was always going to equal 5 in this particular case now, no matter what the y value was. Okay? So what that means is that x has to equal 5. X will always equal 5. So there's your equation. X has to equal 5. So over here, when we're dealing with a vertical line, we're looking at an equation with only the variable x. So when we're looking at a horizontal line, we're dealing with an equation with just the variable y. When we're looking at a vertical line, we're looking at an equation with just the variable x. So if you're given a vertical line containing a point, then you're just going to look at this x coordinate right here. Now in your mind, it helps to have this drawn. But basically it's just this this x coordinate. So x equal 5. Okay, so it does help when given situations like this and you need graph paper to kind of help you understand the situation, then use a graph paper. So in letter C, you're told the slope is 0. Well, remember, a line with slope 0 is a horizontal line. So you have to remember that. So if you have a line whose slope is 0, that means that line is a horizontal line. And then that takes that back to this situation here. So you have this horizontal line that contains this point. So if you have a horizontal line containing that point, again, we now know that if you have a horizontal line, it's going to be y equals a number, and it's going to be this y coordinate right here. So again, if I were to draw this, and it may help some of you to actually draw this line, so -4, -7, so -4, -7 is right here. And if I draw this horizontal line, if I draw this horizontal line, again, no matter what point I'm looking at on this horizontal line, the y coordinate is always going to be the same. So the y coordinate in this case is always going to be -7. So that means that this line is going to be y equals -7. The equation of that line is y equals -7. All right. In letter D, you're dealing with undefined slope. So remember, a line that has undefined slope is a vertical line. All right. And so in a vertical line, the equation is x equals a number. All right, just like we did in letter B. So it may help if you have this drawn in a coordinate plane, and you would see that you are dealing with a vertical line and that the x coordinate is always the same. So it means that x has to always be 6. So letter E is the same as the other. So again, you're dealing with the fact that you have a line whose slope is 0. Well, that means that this line is horizontal. And so you're going to have y equals a number, and you just look at this y coordinate. So it's y equals 0. All right. Now, number 2, you want to find the equation of a line with a given slope and passes through this point. And all you want to do is just write the equations in slope-intercept form. All right. First of all, we're going to use point-slope form. So we're going to use point-slope form. Okay, and remember, point-slope form is y minus y1 equals the slope times x minus x1. All right, and so I'm just going to plug these values into this formula. So in place of this formula, 2 is going to be substituted for x sub 1, and then -4 will be y sub 1. And so I get y minus y1, which is a -4, equals the slope, which is 3/4, times x minus 2. Now you need to rewrite y minus a negative number. So remember, when you change a subtraction to addition, you're going to say add the opposite. So this becomes y plus the opposite of a -4 is a +4, equal, and then 3/4 times x minus 2. Okay, now this right here is point-slope form. That's what this is. These two are point-slope forms, but I want to change it to slope-intercept form. So in slope-intercept form, first of all, I've got to get y by itself. No, you're right. So remember, slope-intercept form is y equals mx plus b. That's slope-intercept form. So I get y by itself. So I'm going to distribute the 3/4. So I get y plus 4 equals 3/4 x minus, and then that's 3/4 times 2. Really, it's -2, but I already have that subtraction here. So I'm just going to go here and see what 3/4 times 2 is. And then I'm going to reduce. 2 into 2 is 1. 2 into 4 is 2. So I'm going to get 3 times 1 is 3. 2 times 1 is 2. So that becomes 3/2. Alright. Then to get y by itself, I'm going to subtract 4 from both sides. And so I get y equals. Alright, so y equals 3/4 x. Alright, now I got to figure out what a negative 3/2 and a negative 4 is. So negative 3/2 plus a negative 4. I'm going to write just negative 4 over 1. And I have my calculator with me, so I'm going to do this by hand. So the LCD is 2, so I'm going to write equivalent fractions with 2 as the denominator. So since this fraction rational number already has a 2 as the denominator, and I want to write an equivalent fraction with a 2, that means that if the denominators are the same, then the numerators have to be the same. So negative 3/2 is equivalent to itself. Over here, I want to write an equivalent fraction that's equivalent to negative 4. So I have this denominator 1. I really want to write an equivalent fraction with the denominator 2. So you can say times 1 times 2 is this 2. But what you do to the denominator, you have to do to the numerator. So negative 4 times 2 is negative 8. So in your mind, you do see that negative 8/2 is equivalent to a negative 4. Alright, now since the numbers are the same, I can add their numerators. So negative 3 plus a negative 8 is a negative 11. So I get negative 11/2. Alright, and so there's your slope-intercept form. So y equals 3/4 x minus 11/2. And always verify that this slope here, remember once you get y by itself, the coefficient of x is your slope, mx. So make sure that this right here matches what you're told the slope is. Okay, and so that takes care of the key to worksheet 10.5, part E.